This is a lecture over 1.1. We don't spend a whole lot of time in class with this section, along with 1.2 and 1.3. So I decided to give you a little mini lecture over each of these three sections. So I'm going to begin with 1.1. And 1.1 I'm going to teach in two parts. And 1.1 has got to do with solving linear equation. This is a intermediate algebra concept. Uh, it's just a beginning concept here in Math 135, but it gets us off on the right foot anyway. And so solving linear equations, the ones that we're going to be doing, these are the 5 steps that we're going to be saw how to solve these. And these are a little different than the way the book does. I don't teach exactly the way the book does it. If you want the way the book does it, you can read the book yourself. So I do it a little differently. But the steps to solving them is multiply by the least common multiple if you have to. And you only want to multiply by the least common multiple if they have fractions in them. And these that are my two examples will have fractions. And so after you do that, distribute and simplify. Actually, should be a D there. Distribute and simplify if necessary. Okay. Isolate the terms with variables on one side and non-variable terms on the other side. So basically, it's a plan of musical chairs. You put terms that have variables on one side of the equation, usually the left, and the non-variable, the terms that don't have variables in them, on the other side. And that's usually the right side. But it's not necessary to do it that way, but because you can put the variable on the right if you prefer to do that. Simplify step 3 and solve. So after you put the variable terms on one side, you can combine them and put the non-variable terms on the other side and combine those. Just be just combining numbers though. And then step 5, check for restrictions, because sometimes when you have variables, you cannot divide by 0, so sometimes your answer is extraneous. And so you throw out extraneous solutions. Extraneous solutions basically mean you solve the problem, you make no mistakes, you get an answer. Unfortunately, the answer just does not work because it makes the denominator 0. So when that happens, and I'll tell you up front, example 1 and example 2 are not extraneous solutions. The ones that you're going to get there are going to be legit and they're going to work because there's not anything that's going to be making undefined. So we'll begin with these two examples. Example 1, 1/2 p plus 1/4 p equals 6. So the first thing I'm going to do is multiply by the least common multiple. The least common multiple is 4 because the denominators are 2 and 4. So the least common multiple of those two numbers is 4. So I multiply both sides of the equation times 4. And a lot of times it's just, well, why do you multiply by the least common multiple? Well, you want to clear out the fractions, because when I distribute this, it's going to cancel the fractions out, and that's the whole point of step number 1. So 4 times 1/2 p, so distribute and simplify. So 4 times 1/2 p is 2p, and 4 times 1/4 p is just plus 1p. And then 4 times 6 is 24, of course. So I've simplified it. So step 3, isolate the terms with variables on one side. Well, they're already there, so it's pretty nice. This one's a pretty nice problem. And so because the variables are already on one side. So 2p plus 1p is 3p equals 24. And then simplify this step. So I did that, and then solve it. Divide by 3, isolate the p, and so p equals 8. And 8 does not make the original problem undefined. As a matter of fact, nothing would make it undefined because there's no variables in the denominator. So 2 will never be 0, 4 will never be 0, and p is not in the denominator to begin with. You might think, well, 0 is not allowed because it's a restriction, but 0 would have been allowed if it was indeed the answer, because p is not in the denominator. So it's only the things that are in the denominator that would make it undefined. We'll encounter those problems in a minute. So p equals 8 is the solution. Then you can check your answer. 1/2 of 8 is 4. So, and then 1/4 of 8 is 2, and so 4 plus 2 is 6. You don't really have to check them, but it is nice if you have a little bit of spare time just to make sure your answers are correct. So that's example 1. Example 2, same idea. The least common multiple here is 2x, because this one's got 1x and this one's got 2x. And if you don't pick the right least common multiple, you'll know, because when you just start distributing, the fractions are still going to be there. They don't cancel. So if you don't pick the right one, you'll know at the very beginning. So 2x is the least common multiple. So you multiply that 3 over x plus 4 over 2x, and then multiply 2x times the other side. So, and distribute. So 2x times 3 over x. The x's cancel. So 2 times 3 is 6. And then 2x times 4 over 2x, the 2x cancels. And then, so 2x cancels totally. And so it just leaves you with 4. All right. And then 2x times 5, of course, is 10x. And then 6 plus 4 is 10. 10 equals 10x. So isolate the x, so divide both sides by 10. And so x equals 10 divided by 10, which is 1. So, and 1 does work. Again, you can check if you like to, but it's not really mandatory to do this. But 3 over 1, that's 3. And then 4 divided by 2 times 1 is 2. So 4 divided by 2 is 2. And 3 plus 2 is 5. So that does work as well. So my next part 2, this is part 1 right here. Part 2, I'm going to give you 2 more examples. And the problems are just a little bit more difficult.